Okay, so today I'm going to be discussing the rock cycle, going from igneous, sedimentary to metamorphic. I'm also going to be discussing the stages in between, as well as giving a few examples for each cycle. Okay, first off, we're going to start with magmas or lava. This is the beginning of the cooling and crystallization process. This process can occur within the earth or above it, creating different kinds of rocks, which we'll be discussing in the next slide. The first stage of the cycle is going to be the igneous rocks. These are formed from the solidification of magma or lavas. Here I have two types. You're going to have extrusive and intrusive. The difference between them is one will crystallize above the Earth's surface and then the other below the Earth's surface. Because of the different crystallization processes, this does cause differences in the crystallization and the size of the crystals. To the left, you'll see basalt, which is an extrusive. Since it undergoes a slower process, the crystals they undergo a faster process. This gives it less time to cool, causing the crystals to grow a lot smaller. And to the right, you'll see pegmatite. With this, it cools a lot slower, so the crystals have a lot more time to grow, giving the crystals a bigger size compared to the extrusive. After going into the igneous rock phase, you can go into two different processes: weathering erosion or heat and pressure. Let's start out with weathering and erosion first. When going through weathering and erosion, you will get what is called loose unconsolidated sediments. These are basically igneous rocks that were damaged or broken up during weathering, like in the ocean, different types of ways. You can see through the arrows that weathering and erosion comes through different phases, but we'll be discussing that a little bit later. Next, I want to point out the next phase, which will be the diagenesis and lithification. Okay, diagenesis is the physical and chemical changes occurring in sediments, and lithification is going to be more of the conversion of sediments to sedimentary rocks. It's kind of like compacting and the sedimentation of the rocks. So after undergoing the diagenesis and lithification process, you will get your sedimentary rocks. These are formed by the deposition of materials at the Earth's surface within the bodies of water. Here we have three different types: clastic, chemical, and organic. Clastic, which is the most common, is formed from cement and sediment grain from pre-existing rocks. In this photo here, we have a breccia. Next, we have chemical, which is formed by the precipitation of minerals from a solution. With that, you get a more crystalline texture compared to the other two. In this photo, I have rock salt, or salt rock, or formerly known as halite. This is formed from the evaporation of the ocean or saline lake waters. And the last one is going to be organic, accumulated from remains of organisms. In this image, I have coal. This coal was actually formed from plant debris, hence the remains of organisms. Next, I have the next process, which is heat and pressure. With this, you can go from igneous to metamorphic or from sedimentary to metamorphic. Now we're on to the last and final phase. This one's the metamorphic rocks. These form from pre-existing rocks which are transformed into new rocks by heat and pressure below the Earth's surface. So when you think of metamorphic rocks, always think of heat and pressure. With here, you have two different types. We have foliated and non-foliated. To the left, we'll start with foliated, which is layered or banded appearance that is produced by exposure to heat and directed pressure. In this picture, my example I gave you was gneiss. As you can see that the different lines going up and down cause of a banded appearance, kind of a little bit like a layered. To my right, we have non-foliated, which in this picture, I have quartzites. Non-foliated is where you do not have layered or banded appearance. As far as heat and pressure goes, gneiss you can get from granite, igneous. And as quartzites, you can actually get that one from sandstone, which is a sedimentary rock. All of these undergo heat and pressure. And after your final stage of the metamorphic rock, we go back under heat and pressure, leading back to the stage of magmas. Let's go over the process one last time. We're going to go from magmas, cooling crystallization, to igneous rocks, which can undergo erosion and weathering, which can lead to sediments. But igneous can also undergo heat and pressure, which will lead to metamorphic. Sedimentary can come from sediments. Sediments can go to metamorphic. Metamorphic can even go back to sediments. After everything, metamorphic will always come back to a magma. Now let's review with a little bit of questions. What is the process of lithification? Name the two types of igneous rocks and what makes them different. What happens to granite after the process of heat and pressure? Give you a couple of minutes to answer those. Okay, lithification is a conversion of sediments. Always remember that. It's when the sediments become compacted and cemented into a sedimentary rock. Extrusive is formed over the Earth's surface. Intrusive is formed below. And then granite, like I said in the beginning or in the end, will always become a gneiss under heat and pressure.